Good morning or good afternoon, everybody. Welcome to Machinations 101 webinar. So today we're going to be going through step by step and give you all a solid understanding of the building blocks of Machinations. And we're going to help you to master the different run modes, get familiar with the chart and its usefulness, and learn some tips and tricks on keeping the diagram tidy as we go along as well. Before we get started, just down at the bottom of your screen somewhere, you'll see a little chat button. If you want to just hit that chat button, and then the first thing to do is just change who you're sending your chats to. As default, it'll say all panelists. If you could change this to all panelists and attendees, that would be great. And then once you've done that, if you can let everybody know where you're dialing in from, whereabouts in the world you are, and which studio you're from, that would be great, just so that we can see who we've got with us today. Let me introduce myself. I'm Matthew. I'm the evangelist for Machinations. Someone asked me if I made these games. I wish I had. I just played a lot of them, and they're great fun. With me today, as always, is Cesar, our diagram craftsman. He's going to be setting us some fiendish puzzles today and helping us all learn about Machinations. In the chat, we've got Mihai, our CEO and founder, lurking about in there, answering any questions you have. He's even brave enough to put his camera on for us today, a rare treat, as you'll all know. Throughout today, please do, if you have a question or you're not sure about something, please do drop it into chat. If you're not sure about something, I'm sure there's somebody else that's stuck on that same question. So please do ask them as we go. We'll have time for hopefully for some Q&A at the end. And throughout this webinar, normally we ask for your input. This time we're going to be testing your knowledge to make sure you've learned everything. And we're going to be doing that via polls. So I'm going to launch the first poll. How complex are your machinations so far? And I'm going to use that to just secretly switch over between my screens into machinations. That's me practicing. Great. I'm going to close the poll in a couple of seconds. Drop your answer in there. 3, 2, 1. Let's have a look at the results. So most people have been doing some doodles, which is fantastic. Plenty of people that haven't used Machinations before, and a few people are already doing kind of full meta, but which is great. Hopefully there'll be something for everybody today. No, I didn't. I pressed the wrong button then. I didn't click stop sharing results. There we go. So first things, hopefully you can all see my screen. Cesar, give me a thumbs up. Brilliant. So this is the Machinations platform. And what I'm going to do is quickly run through everything that you can do with Machinations in one go. First up, over the top left-hand side here is our menu button. This is where you're going to be able to create new documents, open up our templates, and all the usual sorts of things from up there. Down the left-hand side, we have all of our objects that we're going to be walking through today. Just to quickly show you our libraries. So our libraries, our public ones, we've created lots of different templates to help you learn Machinations and to get you started. If you have one of our subscriptions, you'll see your private and even your team libraries. So this is where Cesar and I have been collaborating, building some models for different projects we're doing together. So let's start making some models. First thing you can do is drag these items into the canvas. Nice and simple. Then let's add another object. So this is one of our pools. On the right hand side here, when you just click the canvas, there's a few options. First one's the grid. That's just going to put this grid to help you line everything up. I keep that turned off because it looks terrible over Zoom screen sharing, and I want it to look nice and neat like this for today. Also have connection arrows and guides. So with the guides on, you'll see these little blue lines helping me keep everything lined up. Great for my OCD. I like everything nice and level. The other option here is the connection arrows. You'll see when I hit the connection arrows, it's going to add the same type of resource as the previous one, and it's going to do it in any direction that I want it to. The other thing that we can do with these is hold down the mouse button and drag them to create those connections. As well as being able to do things like that, if I double click one of these items, no, lost it. Let me move that back. if I actually double click it properly, it's going to add that, and it's going to add the connection along with it as well. I'll zoom in a little bit more. So just by double clicking one of these objects, it's going to add it onto the canvas. If I hold shift, if I click it normally, it'll just put it to the right. If I hold the shift key, it'll put it above. And if I hold the control key, it'll put it below. So you can quickly start to add your objects onto the canvas as quickly as you like. Now, for today, I've already built out all of these models, and each of these I'm going to walk through down the left-hand side and really go through in detail what each of these different objects does. And we're going to kick off at the top with our sources. So sources create resources into the canvas and into our models. So when I hit play, you'll see each of these sources has 4 different activation types. Passive means it's going to wait for something else to trigger its action. Interactive means when I click on it, it's going to send one resource, and it's going to create one resource and send it into whatever it would be over the resource connection. Automatic means it's going to send it every step, depending on how the flow rate that we've set on the resource connection. And if I hit play again from the start, you'll see this on start behavior where it's only sending the resource during the very first step of the simulation. So it's not going to do anything else, and it's going to sit there and wait just as if it was a passive source from then on. Once we've created our resources, we're also going to want to get rid of them at some point. So here we have our drains. Drains, they have the same 4 activation states as sources. So up first we have passive, which is, again, it's just going to sit there waiting for something to trigger its action. Our interactive, so if I click on this, you'll see it's pulling resources and it's draining them out of our simulation. Our automatic is going to drain those resources every step. And again, our on start activation means that it's just going to carry out its action on the first step, then it's going to wait there passively. The other option that we have with our drains is we have pull any and pull all. So here we have some examples of our pull all feature. You'll notice if I click on here, the little arrow's flashing, but it's not doing anything. It's going to wait until there's 5 resources available in this pool to be able to drain them. So if I click on here, it's not going to do anything. Wait till there's 5, click again. Now it's going to drain that pool. So the all characteristic, and we'll see this on quite a few of the different objects, it will only fire its action when it can pull the number of resources that it needs, in this case, 5. And again, with our automatic pull, you'll notice that this is carrying out its action every step. So that orange line flashing around the resource connection, waiting till there's 5, and then it's draining them. Just to show you a comparison between these two, with pull any, it's just going to carry on pulling them even if there isn't 5 available. And in this situation, it would pull up to 5 resources. So if there was 6 or more in there, it would leave those excess ones in the pool, but it's just going to pull them across each step. And again, as always, with a pull all, but on start, you'll notice because there's not 5 resources in here, it's then just going to sit there passively waiting for it to be triggered by something else. On to pulls. And please do, if I'm going too fast or you have any questions about sources or drains, please do ask them in the chat or in the Q&A. So up next, as we move down the left-hand side here, are pools. Our pools are for storing resources at some stage in the simulation. So again, we have the passive, interactive, automatic, and on start. As I hit play, you'll see our passive node. Again, it's passive. It's just going to wait there to be triggered, so it's not going to do anything. Our interactive node, when I click on this, it's going to pull 1 resource over each time I click on it. Our automatic node is going to pull 1 resource in. So you'll notice here that all of these sources are passive. So the source doesn't have to be active because it's being effectively triggered by another object. So our automatic pool is pulling those resources over. And our on start characteristic is just pulling one resource over at the start. Now, one thing I know I got caught out with a lot when I first started using Machinations is both objects are automatic. So if we have an automatic source and we have an automatic pool, although we just have a 1 between these two on the flow rate of the resource connection, when I hit play, you'll notice 2 resources coming over. That's because both ends of this connection are triggering that flow. So this means that you could end up doubling the flow rate between 2 nodes if you're not careful. So I know I definitely got confused with that when I first started using Machinations. Now, as well as pull any that we've just seen, we also have the ability to push any. Now, in these configurations, this pool doesn't have anywhere to push the resources to, and it's got nothing pushing resources into it, or it's not pulling any resources. Therefore, when I hit play, you'll notice it goes to this grayed out configuration, and it brings up that error to say why it's grayed out that section. So this is missing input resource connection or trigger. And even with the interactive, it's missing the active connections because it doesn't have anywhere to push resources. So let's have a quick look at a push any where it's got something to push them to. So here I have a source. It's going to push 10 resources into these pools on start, just to give us some resources to play with. Passive, again, it's not going to do anything. Our interactive, when I click on this, it's going to push 1 resource into the next pool. Our automatic one's already draining out and it's emptied everything. And again, on start, you'll notice because this pool didn't have any resources in the very first step, it's not going to do anything. It's just going to sit there passively from now on. Just like drains, as well as pull any, we also have pull all. So if I try and trigger this when there isn't 5 in the previous pool, it's not working. Once there's 5, it will then pull those 5 across into this pool. Our automatic one, triggering each step, it's going to build up those 5 resources and then pull them over into this next pool. And just to show you the comparison, just like drains, even though this is the flow rate set at 5, it's going to pull 1 in and it's going to pull up to 5 resources each step without waiting for that pool to be filled up first. And again, just on start, because there weren't 5 resources in here the first step, it's not going to wait until there's 5 and then pull them. They weren't there at the start, so it's not going to take any action. In just the same way, as well as pull all, we have our push all action. And this is going to, just like before, it's going to wait until there's 5 resources in this pool to push them. So as I'm clicking on this, it's not doing anything. Wait, once there's 5, it's then available to push. Just like our automatic pool is pushing these as soon as there's 5, and you'll see it's flashing its orange color to say it's trying, but it can't complete its action. 2 more things just to show you about pools. As I hit play here we're using a display characteristic here of 25. That means once the number goes over 25, start displaying the actual number. On the right-hand side here, I've set the display to -1. This means that it's going to show the number there all the way from 0. If I set that to 0, as you might think, it's going to show a blank pool. And then once resources enter the pool, it's going to start to show the number. But I like to see the 0 in there, so I'm going to set that at -1. So that way, as it counts up and as it starts adding the numbers, it's going to count them and I can see the whole numbers there. Very last thing to show you with pools, we have one more criteria, which is overflow. So this pool, we've set it to automatic pull any, so it's going to pull these resources in from the previous pool, and it's using the block characteristic. When I hit play, we've set the capacity at 4. This is going to pull 4 resources in from the left, and I'm in there. And once it reaches 4 in a moment, it's then going to stop pulling any more resources over from that pool. I might just need to refresh. Just one moment. Too many layers going on in my model. Here we are. So here's my limit of 4. I'll hit play. It's going to pull those 4 resources over. Once it reaches 4, you'll then see it's stopping and it's not pulling any more over. With this one, when I hit play, we're using the drain overflow characteristic. That means once it reaches 4, it's going to carry on pulling resources over, but there's not going to be any space for them, so it's going to drain those resources away. One thing, again, just like the double activation, one thing to look out for is push-pull. So here we have a pull, so it's set to pull any. So it's pulling resources over from the source. Here we have a push any configuration. This means that this pool is trying to push resources out of it. That actually means there's nothing to activate this connection between the two pools. So here we're pulling, here we're pushing. That means nothing's going to move between those two. So I certainly got caught out with this quite a lot when I first started using Machinations, and I would try and be very confused why my resources weren't flowing the way I expected. Now, Cesar, I think you've got some fiendish questions for us. Do you want to talk us through what we've got here?
Yeah. So the questions, you can see it on the screen. How many resources will the pool in the middle have after 3 steps? Pay attention to the activation of each node, and pay attention to each of the connections, origin and output.
Excellent. As a little test, we're going to pop a poll up on the screen. So the question here is, how many resources will the pool have after 3 steps? So this pool in the middle here, we've got the option of it's either going to be 3, 6, or 18. So enter your answers. Maths on your fingers, trying to work this out. So we've got an active automatic source, we've got an automatic pull any pool, and we've got an automatic pull any drain as well. And we've got a 4, a 1, and a 2. So I'll give you a couple of seconds just to pop your answers in. Is it 3, 6, or 18? I think you're going to catch a lot of people out here, Cesar. Right, I'm going to end the poll. Let's see. So let's see what happens. Step 1. Now, because although this is 4, we've got an active source and we've got an active pull any pool. So that's pulled 8 resources across. Let's do the next step. So here we had 2 go to the drain and 1 go to the drain. One more step, and we've ended up with 18. I'll share the results. Kudos to whoever got that one right. That's super tricky. Cesar's really trying to catch us out with these as we go through. Cesar, while I find the next section, what would you typically kind of use pools for in your models?
Sure. Let's go through all 3 of them while we're at it. So let's begin with sources. Sources, in a way, can be considered pools with an infinite amount of resources. So when you have an entity that is able to supply an unlimited amount of resources, say a bank that gives money, say when you're giving healing to a player, since the healing comes from nowhere virtually, think of it as any entity with an infinite amount of resources that's able to constantly supply in multiple directions at once. That's basically a source. A drain is, as Matthew said, a node that is used to destroy resources. In this case, think of it as a player losing health. That health will probably go into a drain. Think of a player spending money. That money is will probably go into a drain. So drains are used solely to destroy those resources. And pools are the storage node of Machinations. So whenever you want to keep count of something, say the player's balance, the player's currency balance in a game, you would probably store that in a pool. The amount of items a player has in his inventory, that would probably be stored into a pool. The amount of materials, maybe his HP as well, his armor, all of this stuff is usually stored into a pool because you can both receive items and lose them. So they are usually manipulated by sources and pools and drains, sorry.
Perfect. Thanks, Chesa. So up next, we're going to carry on our journey down the left-hand side here, and we're going to talk about gates. So gates are often where we're kind of making decisions or choices or giving multiple options. Again, we've got those same passive, interactive, automatic, and on-start activation modes. Here's my interactive. You'll see when I click on this, it's putting one resource through and popping it into the pool. Automatic is going to fire each step, and you'll be quite used to this by now. Our on-start is only activating on the first step. Just worth noting that gates actually do all of their action during one step. So even multiple gates can all be passed through in a single step. You'll see here, it looks a bit different, but actually both of these pools are filling up at the same rate. Now, this is a much more common configuration of our gates, where we have multiple options coming out of these gates. You'll see that as resources come through, they're being distributed between the two output connections, as well as doing it deterministically. So you'll see here we have deterministic or random. We can also randomize this. So this means that it's going to be distributing these resources based on our Monte Carlo simulation and randomization. So this means that they're not going to be perfectly evenly balanced as they go through, but it's going to be using those odds each time. And you can see the number flashing up on the gate to say which route the resources are going to take. These can be done as well as with whole numbers. They can also be done with percentages. So here is a deterministic gate using 50%, 50%. So it's going to distribute these accordingly. We also have the option here of randomizing using percentages. It's really important. You'll see this grayed out behavior when I hit play. That's because you can't mix whole numbers and percentages after a gate. You have to have all the same types of connections coming out of it. Now, if the odds are less than 100%, you'll see that some of these resources aren't coming back out of the gate. So they're actually being drained. So 50% of the resources that come in here are just going to be drained by this gate. If the odds are over 100%, this means that actually it's going to just use that same ratio. So it's quite important, and quite a lot of the different models that we'll do, we did recently in our webinars, we don't want the total to drop below 100%. So we'll actually kind of multiply everything so that our total odds are always over 100%. So if we turn off one of these connections, we're not going to lose any resources coming through the gate. As well as our activation states and our distribution model, as always, we have our pull type characteristics as well. So we have pull any and pull all. Just as you've seen before with pulls and with drains, they're going to wait until the previous connection fulfills its requirement. So here we have 5. It's waiting till those 5 are required, then it's sending them over. One of the things you'll notice here is that these are 50-50. It's deterministic, but you'll notice that each time these 5 resources come in, it's an odd number. So that time 3 went to the bottom, 2 went to the top. This time 3 will go to the top and 2 will go to the bottom. So the gate will remember what happened in the last step to make sure it's sticking to the correct ratios, although it's dealing in whole resource items. So it's not going to send 2.5 resources to each node. It's going to send 2 and 3, but it's going to make sure that it balances out over the series of steps. And that's an important thing to know about with gates. It's not going to just put 3 into the top one, 2 into the bottom one each time. And again, we can do that same sort of behavior, but this time using whole numbers and random gates, just as we saw before. So you'll see that this will then fill up at different rates. So we had 1 there, 4 there that time. One last use of gates is to actually use these as triggers. And we're going to talk about state connections in quite a bit of detail later on, but just to quickly show you these models are then, we're using a gate to trigger our sources. So these are distributing the triggers by 25% each time. That means 50% of the time it's not going to trigger either of these. And then once every 4 steps, it's going to trigger one of the sources to send a resource into that end pool. And here we have it, the same model, but this time with randomization. This way, it's going to randomize how many times it's going to distribute these based on these percentages. Now, Cesar, I think you have a fiendish question for us about gates. Here we go. Do you want to talk us through it?
Yeah. So Matthew cheated a bit today because he insisted on the proportion example earlier. So he actually helped you a bit here. But keeping in mind what he said earlier, pay attention to the proportions, taking into account the fact that the input resources do not equal to the amount of output resources, and think about how the gate will handle the situation.
Actually, just to make this clear, I'm going to change this slightly. I'm going to make this a drain instead, so it's clear which.
Yeah, we were referring to the top pool. The original example had a drain there. So
did we have this as 2 and 1 before? We did, didn't we?
Yeah.
I'm going to change it. So we've got an automatic source. We've got a passive gate, but that's okay. The source can push the resources all the way through. The question is, how many resources are we going to have in this right-hand pool after 3 steps? I'll put my question back over it. Send it to the back. No questions. Send it to the back. I'm moving things between layers. There we go. That's better. And I'll open up and launch my poll. How many resources are we going to have in the pool after 3 steps? People straight in with some correct answers. I'll give you a couple of seconds. 5, 5, 5. It's going to be 15 coming out of the source. How are they going to be distributed? Perfect. We'll give you a couple more seconds. I'm going to close the voting in 3, 2, 1. Have a guess if you're not sure. Here it comes. Right. Brilliant. We've got lots of people with the correct answer this time. Let me give you let's have a look at what happens. So I'll do 1 step. So we've sent 5 through, 3 have gone into the top pool. 1 more step. This time 3 went into that top pool. 1 more step. And then we've got 10 resources there in total. So everybody that put 10 resources, give yourself a pat on the back. That's it is quite tricky getting into grips with these gates and these odds. So well done. Cesar, what would we use gates for in our Machinations models?
So gates are your friends when you want to distribute resources in many directions. So say you, especially for random cases, so say, let's take, for example, Minecraft enhancement. You can have a lot of results, enchanting. You can have a lot of results when enchanting an item. You do not know the outcome. The outcome is pretty random. In those cases, you would use a random gate to send your the enchantment that the player would get. Enchanting any item in any game. Finding random loot from a monster also would probably go through a random gate because the drops aren't always guaranteed. And if there are drops that are guaranteed and say they are different, say you get a pelt and a gem, you would create 2 resources, send them through a deterministic gate that would split 1 to the pelt pool and 1 to the gem pool. So gates are exclusively used for distributing resources, but they're the go-to node for that. So,
excellent. Thank you, Cesar. certainly use gates a lot. You'll notice here, those eagle-eyed amongst you, I'm going to move on to traders in a moment, but I'm just going to talk about converters first. They're a bit easier than traders. So converters, as the name suggests, are all about converting resources into a different value. So as I hit play here, you'll see my automatic one. It's going to pull 5 resources in one side. It's going to fire out 1 out of the other side. Here's an example. I'm pulling 5 in with my interactive node, and I'm producing 15 on the output side. And of course, as always on start, it's just going to fire these through just on the first step, and then it's going to sit there passively waiting to be triggered by something else. Just like gates, our converters all act within the same step. So you'll see here that resources are flowing through and arriving at this end pool at the same time. As well as we've seen before with all of our other objects, we have a pull any and a pull all. The important thing to note here with converters is if I click on this pull any converter, in the top right hand side here, you can see it's counting up a number of resources. So those resources are being drawn into the converter, but it's waiting until its criteria are met to fire them into the end pool here. So it's still doing it, but those resources are hidden. So it's important if you wanted to see how long it takes for a player to accumulate the coins, or how many coins have they got there, or whatever resource it would be for your game, you might want to make sure you're using the pull all criteria. One of the beautiful things about converters is you can actually have multiple incoming connections coming into them. So here's an example of a pull all and a pull any configuration using 2 different sources. The important thing here is you'll see the pull any, it's emptying this bottom pool quite happily. So actually it's counting up the number of resources it's storing, but it's only releasing those resources once it's got 5 from the top pool. With pull all, it's leaving those resources in that previous pool before it's pulling them in and converting them into a single counter on the right-hand side. It's important to note you can have multiple inbound connections into a converter, but you can only have a single outbound connection. So when I hit play here, you'll see this is grayed out. It's bringing up my error message to say you can only have exactly 1 active output resource connection. If we did want to, say for example, we wanted to show a mechanic of a player breaking up an object and it was going to be split into several different types of components, a sword might be split into wood and iron, for example, we can actually then use a deterministic gate to simulate that action. So here we've got a pull all converter. It's going to pull those 5 resources in, convert them into 8, and then we're using a gate to distribute these as 5 and 3 to simulate breaking up this object into its constituent parts. Now, Cesar, I think you've got another fiendish puzzle for us. Do you want to talk us through what we've got here?
Sure. So there's not any activation shenanigans going on here. It's a fair and square this time. As you see, the source will send 15 resources forward. We use 1 pool to distribute those resources with 2 different resource connections into a pull all converter, which converts them into 1 final resource. So after 3 steps of execution, how many resources will be in the rightmost pool?
Excellent. I'm going to pop up the poll. Give you all a few seconds. So we've got 15 resources coming into our pool, 1 into our converter and 3 into our converter. It's set to pull all, and then we've got an output of 1 resource coming into this pool. And how many are going to be here after 3 steps? Great, I can see some people getting it right, some people being caught out by you again, Cesar. All of these are super fiendish, but hopefully they'll all help you get a better understanding of how Machinations works. So don't worry too much. I saw somebody raise a hand. I don't know if that was by accident, but if you have a question, please do chuck it into chat. If you want us to, I could bring you in and allow you to talk and ask us a question if you'd like to. Yeah, let's bring Kenny in if you're okay to talk to us. Hi, Kenny. Did you want to ask us a question? You should be able to unmute and ask us a question now if you want to. No, fair enough. Right, well, I'll end the poll. And let's have a look at what happens after 3 steps. So after 1 step, we've got our 15 resources in there. Next step, our converters fired and produced 1 resource at the end there. 1 more step, and we now have 2 resources in that end connection. So if you got that right, well done. If you got caught out by the number of steps there, don't worry, you're in good company. Talk us through what happened there then, Cesar.
Yeah, so there's 2 sort of traps that I laid out here, but most of you figured the first one. The first one would be that converters only convert once per step. So no matter how many resources you push in there, you could have pushed 1 million resources. The number of conversions would have remained the same. The second one is the one that caught out most people. The fact that it actually takes 1 step from the source to reach the first pool and another step for the conversion to happen. So on the first step, we would have no conversions.
Perfect. Thank you, Cesar. Cesar, what would you use converters for?
Well, obviously for converting, I think it's the best approach for, let's say, an experience mechanic where you transform experience into levels, where you transform stats into, let's say, skills, where you transform, I don't know, currency into an item. You would probably use a converter, drag the currency and convert it into that item. So any type of exchanges which are going to be shown in traders as well in a moment can be done with converters as well.
Perfect. Thank you, Cesar. So next up, we're going to talk about traders. I promised to come back to them. One of the important things to know about with traders is that they use this additional feature of the sources. So as well as our different activation states, we also have resource color. So here you can see I've got 5 different sources. They're all sending different colored resources into our middle pool here, which is then using our filter function on our resource connections to filter them out by color again. This is great if you've got different types of resources that you're trying to track in, and you want to then dump them all into one pool, but then a player is going to use them for different things throughout their journey. Now, the reason that this is important with traders is that we're using this mechanic in our trader to effectively create some kind of trading mechanism. So as I hit play here, we'll have a look at the automatic one. You'll notice it's waiting until it's got 5 resources, because that's what it costs. Once it's got its 5 resources, it's then going to exchange those 5 blue resources for 1 black resource. And it's going to carry on in automatic. It's going to do that all the time. With our interactive, just as we've seen before, we're going to click on this to make it trigger its action. And then we have our on start and our passive, just as you'd expect. I'm going to zoom out a little bit. There we go. And that's pretty much it for traders. So what would you use traders for, Cesar?
So traders are pretty similar to converters, but the difference is that while the converters have a one-way relationship, one resource transforms into another, here you give something and receive something in return. So it's perfect for shop type simulations where you give, let's say, currency or whatever, you trade something, you give your item and you receive another item or stuff like that, because it both creates resources for the other player and creates resources for you as well. So it's perfect for a two-way conversion.
Perfect. Up next in our little journey, We're going to come on to registers in a little while, and I'm going to talk about delays. So you'll all be used to these different activation states by now. So our automatic, you'll see resources are being pulled in here every step, and then 3 steps later, resources start to come out the other side. So it just delays and holds those resources for a few steps, and you'll see it took a few steps for them to come out of the other end. So if I show you that just on the interactive, it comes in here, holds it for 3 steps, and then sends it out. The length of time it spends in the delay node is determined by the label on the resource connection coming out of it. Our delay nodes have got 2 actions. They can either delay or queue. So let's have a look at what this is doing on when it's set to queuing. So you'll see the resources are going in each step, and then they're being distributed and effectively queued up in our delay pool and being released once every 3 steps. So it's a great way if a player is queuing up a number of items. Well, actually, Cesar, why don't you tell us, what would you use delay nodes and queue nodes for?
So queues are for those instances where, let's say you have a game that you train troops in, and the troops are being trained one by one, but you need to wait for one to finish before the next one starts. So you need to queue them up. Let's say you have a cooking game and you want to use the oven, but you can't store 2 items at the same time in the oven. So you put one in there, queue the next ones up. As soon as one comes out, the next one goes in. Delays are for those kind of situation where you have a situation where, let's say, it takes 5 seconds to open a door or something, and you want to for the resource to wait for those 5 seconds because maybe that means something in your game. Basically, any type of situation where there's an action that takes some time to fulfill, let's say cleaning up in a simulation game, or any situation, going to work, let's say in The Sims or something like that.
Perfect. And while you're doing that, I just loaded up our next page. You'll see I've kind of split this between our connections and then our objects. So I'm now on our connections page. Just down in the bottom right-hand corner here, this is where I'm going to hide my questions, and I'm just going to look at our resource connections. Hit fit to screen, we'll zoom you in on any of those areas. If you want to use the outline, just like a mini map in a game, to navigate your way around a model. But let's jump in and talk about resource connections. Now, we've seen these in quite a few times in our model so far. As I hit play, you'll see that with a label of 1, it's going to send 1 resource across this connection each step. With a number of 5, it's going to send 5 across. If I leave this blank, it's going to assume that that's 1 and just send 1 across. Here, we've given it a label of all. As you'd expect, that's going to pull all of the resources available across into here. I've done that with a pool rather than a source, because a source is unlimited and it's going to pull a lot of resources across. As well as doing whole numbers, we can then start to use some different types of labels on these resource flows as well. Here we're using D5. D5 is representing a dice, so it's going to return a number between 1 and 5. So each step, it's going to send over a different amount of resources each time. Can multiply these. So here I've done 3 times D5. Something to be careful of is that this is going to roll 1 D5 dice and multiply it by 3. It's not going to be 3 D5 dice. If I wanted to do 3 D5 dice, I could do D5 plus D5 plus D5. Or if I needed to, I could then set a number plus a random amount as well. So that's going to give me a number between 7 and 11. Using the vertical stroke and then the number, we're going to set the interval rate at which resources are going to go across this connection. So this is sending 1 resource every 2 steps. So you'll see it sends a resource, it misses a step, and then it sends a resource. We can still change the amount of resources, and we can change the frequency of those resources. We can even use our dice symbol there to randomize how often resources are coming across a connection. We can also use percentages on resource connections to say, rather than it being a determined amount of resources coming across, we're going to do it 50% of the time an amount of resources one resource will come across. So you'll see it fires some, misses some, then it'll fire some more. Eventually, when it hits 50%, it won't do it. Now I'm looking at it. Or 2 times 25 will then fire a resource 2 times 25% chances. We can then even do all sorts of craziness and combine all of these different options to create whatever kind of flow rate that we need to with our resource connections. Then jump into my layers, open up my state connections, hide my resource connections. Great way of kind of keeping your models nice and clean and tidy is using your layers and only opening up the parts that you want to see at any one stage. Up next, we have our incredibly versatile state connections. And what we're going to do is look at them using a node modifier configuration. So this is when state connections are drawn between 2 pools. Here we've got a label of +1 on our state connection. This is going to add 1 resource into this right-hand pool for each resource that our left-hand pool receives. We can even do multiples. So with +5, it's going to add 5 resources to the right-hand pool for each resource it receives in the left-hand pool. We can do -1. So it's going to remove resources from the right-hand pool for each resource in the left-hand pool. We can chain these together as much as we like. The important thing here to note is that this is a one-way relationship. So as we fill up our pool here, you'll see that these resources are increasing. But once we drain this pool, it's also draining these other pools as well. This is fantastic if we want to do things like keep a counter. So if this was our coins and we were counting how many players a player had received, we can do this to effectively duplicate that number, but we can then drain this pool as we need to simulate them spending those coins. So this would be how many coins they've collected in the entire game, and then this will be how many they have in their pocket or in their inventory at any one time. Great way of creating that type of mechanic. Do need to be careful if you start draining both of these, because this is a one-way connection and it will have some funny effects. Not funny, but it might not be what you intend it to be. So just be careful with what you're doing to modify these different pools. Worth noting that node modifier configuration only works with pools. It won't work with gates or converters. So if I hit play here, you'll see this is graying out to say it's not going to work. As well as our using a state connection as node modifiers, we can use them as label modifiers. So here we have an example. This flow's got a 0 on it. We're connecting our pool to our resource connection with a +5. This is then going to add 5 onto this connection each step. So you can see it's gradually increasing the flow of resources. Here we've got -1, so it's decreasing this amount, and you can see the number here, it's now reached -10, so no resources will flow between them. And using +1i, we can increase the interval. So you'll see once this receives some resources, it's adding 1 interval to this connection, gradually slowing it down. We can, of course, do -1i to reduce it. We can even combine both of these and have one state connection influencing the interval rate and another one influencing the flow rate. We can get quite creative and making sure that we can simulate any type of mechanic. We can also change probabilities. So here's an example. We've got a 10% chance of a resource coming through this gate. We're using this pool, which is gradually stepping up to increase that rate. Anyone that joined our Endless Runner webinar a little while ago will be quite familiar with that type of mechanic. Obviously, we can do +5, we can do -1, and really create any type of behavior that we want from that. The next use of our state connections are our conditions. So here, we're using a greater than 0. Once this pool receives one resource, it will then allow resources to flow between these. We can do any type of configuration, greater, smaller, equal, so that here we're saying less than 5. Once we have 5 in this pool, it's turning off that connection. And here's an example of just saying only when it's equal to 2 can resources flow. And then we can use greater or an equal. We could even use ranges here. So in this example, when this pool has between 3 to 5 resources, this resource pool will be allowed to flow. You'll notice as I've been going down here, we can also use state connections to influence sources. So in exactly the same method, we're turning this source on and off using these state connections. The important thing to note here is that in these configurations, our source is automatic. So that means that once it's turned on, it's going to automatically send resources. If we had it as passive, that's great that it's going to get turned on by this connection, but actually it's then just going to sit there in its passive state and it's not going to send any resources. Even if we were then to have the end connection set up, this would then work because this is automatic. So this is going to pull the resources through once it's activated by our state connection. So here's a very quick example just showing you can use these conditions with states on any other type of resources. So you're doing a source here, a converter, or a gate. Two more things to show you with state connections. The next one up is a trigger. So triggers will fire, in this example, when a resource is received into this pool. So it's coming through once every 3 steps. You'll see as the resource comes through, it's then triggering our source, which is sending a resource out there. Really common to use these triggers all over the place to activate different types of mechanics. Again, just as I showed you before, here's an example. This is going to receive a resource. It's going to trigger this source. But in this configuration, because this source is already automatic, that trigger is not going to make any difference. So really important to be careful when you're using triggers to check your activation states. If this is automatic already, this trigger is not going to make any difference to it. Here's an example of using a trigger, not just on a source, but on a pool. And we can absolutely use triggers on any other object. So here's a source, a converter, and a gate, all being triggered using that trigger mechanism. And we can even then start to combine and use multiple state connections. So when I first hit play on here, you'll see that this is turned off due to the condition. Once it's received 2 resources, it's then going to become active. Once it receives the next one, it's going to fire the trigger and push its resources into the next pool. The last thing to show you with state connections, I know there's a lot here, are reverse triggers. Now what reverse trigger will do, it's using that exclamation mark, is it's going to trigger its action when the source component cannot complete its action. So here, every time this converter doesn't have the 20 resources it needs, it's firing off this source. So this is a great way of counting how many steps is it taking for a player to be able to earn enough coins to convert into their level upgrade or something like that. Now, Cesar, I think you've got another fiendish question for us.
It's the final one, fortunately.
There it is, final one.
Yeah. So I advise you bring out your calculators for this one. You can see we have a lot of state connections going on. They all originate from the same pool, which is the object of our question as well. The question remains the same. How many resources will the final pool have after 3 steps? So take note of all the different modifiers and the triggers that we have in there. Take note of the activation modes on the nodes, and good luck.
Perfect. And I'll bring up the state connections poll. So will this pool have 1, 13 or 79 whole resources at the end of 3 steps. Some people immediately know the answer, which is fantastic. You probably get there through elimination as well. So this is on start, so it's going to fire some resources through, but it's got this trigger coming back to this source as well. We've got a +1 coming in before the converter and a +2 from our pool into our connection. So I'm going to give you a couple more seconds because I'm running out of time, and I'm going to end the poll in 3, 2, 1. Get all your maths ready. Perfect. I'm going to end that there. Let's share the results. No one fell for our red herring of 79, but let's have a look at what happens. So the first step, we've got 1 resource come through. You'll see that this state connection line has become blue to say it's active. We've got a +2 coming in here, which is going to make this 3. We've got a +1 connection in here, which is going to make it 2. Let's hit the next step. So we've then hit 4. With this +2, it's going to be 9 in the next step and 5 in the next step here. This is still blue because this pool received resources this step. 1 more step and boom, we've got 13. So those of you that got 13, congratulations. Those of you that got put 1 in there, you were caught out by Cesar's sneakiness of using this trigger to activate our on start resource.
Yeah, so that was one of the traps, the on start plus trigger combination. And the other one would be that the input, if you did the math on the input for the converter, that wasn't really relevant. The only important thing was what was coming out of the converter. So congratulations.
Next thing to show you is our end conditions. I'm going to hide my state conditions, bring up my end conditions. So with end conditions, as the name suggests, these are a way of ending the simulation. So if I were to fire 1 resource in here, our state connection going into our end condition is greater than 0, therefore it will end the simulation. This is really important if you want to do some quick runs and you're going to run multiple simulations and you want to know when a certain set of criteria are reached. If the player runs out of lives and you want to end the simulation at that point, add in this end condition and it will stop the simulation and start the next one. Now, obviously we can use our state conditions in any way to activate these end conditions. Last thing to show you today are our registers. I promised to cover everything, and these are a great workhorse of machinations and can be used for just about anything. So in the top left here, let me zoom in, show you this properly. Here I'm using a register to count the number of resources in all of these pools. When you first create a state connection, the default it will give it is the letter A. If you pull multiple state connections into a register, it's going to go A, B, C accordingly. One of the things that blew my simple mind when I found this out was that you can actually, rather than just using single letters, you could even use words on these as well. And here's an example. This bottom one, you'll see in the formula I've got +word. Anything before the colon in here is just going to be used as a label. It's a great way of keeping track of where these connections come from if you start to build up a complex model. So this is now just using this register to count how many resources we've got coming across. The other configuration of a register is to use it as an interactive register. Here it's been given an initial value of 1. I can then hit up on this and it'll increase it. I'm using this to change the flow rate between these, and I can play about with that as much as I like. Really important to note that when I hit stop, it's going to put that number back to its initial value of 1. So if I was playing with this flow rate and I wanted to keep it that way, just update this in the initial value, and that way it's going to update the value so that it'll have the right number in it. And that registers, as I said, incredibly versatile items, and we can use them for just about any type of logics or maths. So here I'm using a formula of if A is larger than 2, and if B is larger than 2, add them together and trigger this source. When the criteria are met, you'll see it's flashing between 1 and 2. I'm using a condition of greater than 0, and it's going to push a resource over. So this is saying if this or this are above 2, trigger this and start counting them. Here I'm using a formula of multiply these two. So if both of these are larger than 2, anything multiplied by 0 would be 0, therefore it's not going to trigger. And here we are, we're counting how many times both of these pools are now over 2. One more thing I'm going to show you for today. And actually, we are going to have a dedicated webinar just on registers, because they are such an incredibly versatile thing, and there's a huge amount we can do with them. Next thing I just wanted to show you is our quick plays. So down the bottom here, as well as you would have been seeing me using steps and play and the different speeds, I can then do quick plays. So here's a simulation we built earlier for Super Mario Brothers. It's a score calculation and it's automated. So in those couple of seconds, I've just done 20 simulations of this game and I've produced all of my results. And I can adjust the number of quick plays I do each time, hit play, and it's going to quickly fill up my chart for me and give me all of that data. Now at this point, I think we're probably slightly over time, as always, but if anybody has any questions, please do let us know. The next thing that's going to happen as part of this webinar is when you leave the webinar, it's going to push you out to our survey. Once you've completed the survey and you click finish on there, it's going to take you directly to our model that you've seen us working through today. It's going to take you through to our objects model. If I open up all my layers here, so you can see all of the examples that we've built out to show you every possible combination, or probably 90% of the configurations that you can do with Machinations. At the top here, there's a link which will take you through to our connections doc, so you can see all of the different connections that we made as well with our resource connections and our state connections, so you can have a really good look at them and see how they work. As always, please do join us on Slack and Discord. And if you want to look into any of the details about any of our licensing or any of our subscription packages, please do get in contact with us anytime. One last thing to show you, down in the bottom left-hand corner here, if you ever get stuck or you need inspiration or you need some help, please do come and have a chat with us in the chat box, and we'll be more than happy to help you out building the models that you need to. What I'm going to do next is I'm going to end the recording for now. And if anybody has any questions or you want to come and have a chat with us even, we can turn on your audio, come and have a chat with us, and we can show you anything else that you're interested in Machination.